And let us move to the another classification category of a kinematic pair. So another classification of kinematic pairs, it can be made on the basis of nature of relative motion between the two links that are forming the kinematic pair. So let us understand this. So the first type of kinematic pair under this category is called as a sliding pair. So as the name suggests, in the sliding pair, the two links, they will have a sliding motion relative to each other. So such a pair is also called as prismatic pair or translatory pair. Now an example of this you can see here. So here this is a rectangular bar, right? You can consider this rectangular bar as link 1. Now this rectangular bar, it is sliding inside another rectangular bar. You can consider this as link 2. So here the link 1 and link 2, they are basically forming a sliding pair. Now turning pair. So in this turning pair, the two links of the kinematic pair, they will have a revolving or turning motion relative to each other. So let's take one example of a turning pair. So you can see here you have a collared shaft. This is your collared shaft, which is enclosed inside a cylinder. Now this collared shaft you can consider as link 1, and this hollow cylinder you can consider as link 2. Now this collar shaft, it is rotating inside this hollow cylinder. So the two, they have a rotating or turning motion relative to each other. So you can see here link 1 and 2, they are forming a turning pair. Now this turning pair, it is popularly called by the name Revolute pair. Now let's move to another type of pair, which is called as rolling pair. So obviously, as the name suggests, in this case the two links of the kinematic pair, they will have a rolling motion relative to each other. So one example of a rolling pair is simple. One example of rolling pair is the ball and or roller bearing. So in this case you can see here these balls, they are basically rolling relative to the inner and outer races. So you can consider this one of the races as link 1, and you can consider this ball as link 2, and you can say here that this link 1 and 2, they are forming a rolling pair because the balls, they are rolling on the inner and outer races. Now screw pair. Now in this case, the two links of the kinematic pair, they will have a turning as well as sliding motion, but it is very important to note down this thing that the turning and the sliding motion, they will be correlated to each other. So one example of a screw pair is a nut and screw arrangement. So as you can see in this diagram, that when the screw, it turns through a certain angle, the nut, it will travel through a certain distance. So let us assume, let's see that how this translation and rotation motion of this nut and screw, they are interrelated to each other. So we know that, let's say for one complete rotation of the screw, let us assume that the nut is going to travel through a distance L, right? Now let's say for a rotation delta theta of the screw, the nut, it travels a distance delta S. So this delta S, it is representing the translational component, and delta theta, it is representing the rotational component. So now we can see the translational and rotational coordinates, they will be simply related by this equation, that is delta S divided by L is equal to delta theta divided by 2 pi. So now since there are two coordinates, right, but these two coordinates, they are interrelated to each other, right? So we can simply say that this kind of arrangement will be falling under the category of a screw pair. Now let us take another example, cylindrical pair. So this type of kinematic pair, obviously the two links, they are going to have a turning as well as sliding motion between them. So the simplest example of this is a cylinder, a solid cylinder rotating inside a hollow cylinder. So you can see here, right, this solid cylinder, if you consider this as link 1 and consider this hollow cylinder as link 2, so this solid cylinder, that is the link 1, it can turn inside this hollow cylinder, that is the link 2, and at the same time it can translate along this axis inside this hollow cylinder. So the link 1, it has a translatory as well as a rotary motion relative to link 2. So such type of kinematic pair is called as cylindrical pair. Now you can very easily say here that, let's say if I am going to define the translational coordinate and rotational coordinate by delta s and delta theta. So these two coordinates, they are independent of each other. So this is the basic difference between a screw pair and a cylindrical pair. Now, what is a spherical pair? So in a spherical pair, the one link is in the form of a sphere and it turns inside another fixed link. So one example of a spherical pair is a ball and socket joint. So here you can see here that this portion is representing this part of this ball and socket joint. It is representing the socket portion. So you can consider this as link 2 and this ball you can consider as link 1. So here you can see this link 1, it is in the form of a sphere, and this link 1, it is going to turn inside this fixed link, which is the socket. So now one example, practical example of a ball and socket joint is simply the hip joint. So in a hip joint, if you see the femur portion, which is in the form of a sphere, it usually turns inside the acetobulum portion of the hip joint. So our hip joint, it represents a form of spherical pair, and the same is true for the shoulder joint in a human body.